Hello students, welcome to the GATE Academy. Today we are going to see another important session of GATEvantage series. GATEvantage series in which basically we are covering 22 most important topic as far as your stream is concerned. So for mechanical, 22 most important topics for your GATE 2022 exams we are covering in this particular series. Today's session we will be covering a very important topic of machine design. The topic will be on clutch and brake. Of course, it is very simple, but as far as the importance is concerned in your GATE exams, which we can understand with the help of the previous years and all, we can say that there is a high possibility, high probability of getting 2 marks or more than that from this particular topic. This thing we will be covering, all the possible concepts we will be covering in this 2.5 hours. Okay, so stay tuned. Clutches and brakes. First of all, let's start with brake. If I will ask from you that okay, how do you define brake? So brake is something which will ultimately bring a moving object to rest, or if an object is initially at rest, so the brake wants that body not to move. The brake could also be used to reduce the speed. Basically, it will be causing the deceleration. Fine. There must be a moving part. There must be a part at rest, and when both of them will come into contact, then ultimately the moving part will also come to rest. Fine. Now how actually this body which was initially at rest will bring the moving body also to rest, that is all which we have to understand. If I will say that what are the concepts which are behind the understanding of this particular topic, so it is simple mechanics. Okay, you should be able to understand that how to find the moment. You should be able to understand that what is the friction force. You should be able to understand that what is the direction of friction force. If you are comfortable with all this, if you are comfortable with the free body diagram and all, then in that case you will be able to answer each and every problem of the brake. Fine, let's start. Let's talk about the classification of brake. So it could be either mechanical, pneumatic, hydraulic or electrical. Of course, we know that we are only concerned about the mechanical brakes. As far as the classification, depending upon the direction of engaging force, if the engaging force in the direction is along the axis, then in that case we are talking about axial brake, or else we are talking about radial brake. Okay, an example of axial brake, you can say that disc brake is your example of axial brake. But the point is that we don't have to study the axial brake, we just have to study the radial brake. And if in radial brake I will classify, then it will be either shoe brake or band brake. Now shoe brake will itself be classified into two types, long shoe or short shoe, depending upon the angle which the block is projecting on the center of the rotation. And band brake depending upon the position of end of the bands. Okay, where the end of band is meeting to the lever. Depending upon that, the band brake is also classified into two. The point is here that we are only concerned about this short brake, simple band brake and the differential band brake as far as our GATE exam is concerned. Clear? So all what we have to understand is this short shoe band brake, simple band brake and differential band brake. Of course, once we will move further, then you will be able to understand that okay, what is short shoe, what is long shoe, what is simple, what is differential. Fine. So let's proceed. Here we are talking about shoe band brake, and by shoe you should be able to understand that what is shoe over here. This block, this is a block, okay, which will come into interaction with this moving drum and will bring the drum to the rest. So here we are talking about block brake or shoe brake, block brake or shoe brake, and depending upon the angle which it subtends on the point of rotation, this theta, we will see that whether this shoe brake is long shoe brake or short shoe brake. If this theta is less than equal to 45. We are talking about short shoe break, or else we are talking about long shoe break. In our syllabus, it is only the short shoe break which we have to discuss. Apart from this block, let me tell you some more terminologies. This will be your drum. This will be your lever, the pivot, hinge. Okay, this is your actuating or activating force. Actuating or activating force. With the help of this actuating force, you are bringing a body which is at rest to a body in contact to a body which is actually initially moving, and then because of the normal reaction force in between them, because of the friction in between them, the body will ultimately come to rest. Okay, normal, however, directly it doesn't affect, but it is the cause of the friction. Therefore, you can say that normal is also responsible for the body to come to rest. Now, as far as gate is concerned, as far as our problems are concerned, what concept we should be able to understand, what concept we should be knowing. Okay, so let me tell you that first of all, you should be able to understand that how to draw the free body diagram of both the parts. Both parts means the drum and your block lever arrangement. This is something which is very, very important, very, very important, and this is only thing important. Free body diagram. The first concept which we should be knowing is free body diagram, FBD. Okay. Now, until unless you haven't classified that whether the rotation of the drum is clockwise or anti-clockwise, you cannot move further. So here in this case, say I am taking a case where the rotation is clockwise, then what will be the free body diagram? Normal action, of course, acting perpendicular to the surface and basically pushing in nature, and the direction of friction. The direction of friction will be such that it will be causing the anti-clockwise moment. How this friction is coming? Because the contact surface have the tendency to move towards side with respect to the body which was in equilibrium, which was at rest. Therefore, the friction on the moving part came to the left side, and from here you can complete the free body diagram of the block as well. So the friction force on the block and the normal action on the block. Apart from that, one actuating force, P is acting, and you can also take the support reactions from here, Rx and R1. Fine. Now, from here, first point you should be able to understand is this friction is how much? This friction is equal to mu times n. This is the first point which you should be knowing from your basic mechanics. Why this friction is equal to mu times n? Because we are talking about kinetic friction, and it is always proportional to n, and after removing the proportionality sign, you always get this value Fr is equal to mu times n. Okay, so there is no doubt that the friction between the surfaces will always be equal to mu times n. If somehow you are able to determine the n, then definitely you will be able to determine the friction force as well. Now the second point is that they asked about braking torque, which is also called as friction torque. So braking torque is the torque which is applied on the drum because of this friction, and you can straight away see that the friction having the moment arm of r about the point of rotation or axis of rotation. So you can straight away say that the braking torque will be equal to Fr into r, mu and r, whatever you want to write. Okay, these two relations holds good. Fine. After that, if someone will ask from me that, okay, what is the relation between normal action and actuating force and how we are going to determine it? It is not possible for us to determine with the help of FBD of the drum. It is only possible for us to determine the relation between normal reaction and P with the help of the FBD of your block lever arrangement. Say this is A, this is C. So here from the FBD of block lever arrangement only it is possible for you to determine the P. Straight away with the help of equation, net moment about point C is equal to 0, you can determine P is causing anti-clockwise, Fr here is causing anti-clockwise moment, N is causing clockwise moment about point C. So you can say that P into momentum. How much is the momentum? A. As far as downward direction is concerned, how much is the momentum? B. And as far as friction is concerned, how much is the momentum? C, small c. Fine. So from here you can say that P into A plus Fr into C must be equal to N into B. Okay, so this is the relation which you should be able to find, provided that you know the direction of rotation, you know the dimensions and all. Fine. So these are the relations which you should be able to understand. If someone will tell us that okay, determine the support direction from pin C at point C, then that also you can find by the FBD of this block lever arrangement using the equation summation fx equal to 0, summation fy equal to 0. Already we know that here, as far as number of unknowns are concerned, Rx, Ry, two unknowns, and Fr and N are basically dependent upon each other. Therefore, you can say that this is the third unknown. So three unknown, you can easily calculate the value of Rx and Ry also if required, or else if it is not required, only the net moment about point C could help you to find the value of P in terms of N. Fine. Basically, these three relations you should be able to understand. Okay. Now let us say that if the rotation is instead of clockwise, say if the rotation is anti-clockwise. Okay, we are dealing with a situation where the rotation is anti-clockwise. Then how the things will change? Once again, the FBD will be of prime importance because the rotation sense is counterclockwise. The friction which will come on the drum will be towards right in this particular case. Normal action can complete the FBD now for block drum arrangement as well. Friction P Rx Ry. Okay. Once again, braking torque same, Fr into R. Once again, Fr same, mu into N. Here if I will ask that okay, what will be the relation between P and N and Fr, then in that case you can say that net moment about point C must be equal to 0. P into A must be equal to N into B plus mu N into C. Okay, as far as the moments arm are concerned. So this is C, this is B, and this is A. So already we know about A, B, C. We can easily say that okay, this relation will be correct. Now if you will observe the equations very carefully, then you can say that in the first case, when the clock in this particular orientation, okay, for this particular ABC, for this particular block lever arrangement, for these particular dimensions, for this particular rotation, you can say that here in this case P can be calculated as N into B minus mu C upon A. I am not asking you to memorize anything, I am just saying that observe it. Here the P is equal to N into B minus mu C upon A. Here if you will ask that okay, what is P? So P will be equal to N into B plus mu C upon A. Now if I will ask from you that okay, in order to get the same amount of braking torque, you need to have same amount of friction. Of course the R is not changing, so friction need to be same. Of course, if you need to have same amount of friction, you need to have same amount of N as well. And in order to get the same amount of N, the amount of actuating force which was applied in this particular case was less in comparison to this particular case when the rotation was anti-clockwise. For this particular arrangement, okay, you don't have to memorize that for clockwise it is the more force is required, for anti-clockwise the less force is required, or for anti-clockwise the more force is required, for clockwise the less force is required. For this particular case only, for these particular dimensions, for this particular orientation only, it is that we are getting that for counterclockwise rotation, the amount of actuating force in order to apply the same amount of braking torque is greater. Fine. So if someone will ask from you that, okay, which one is better, then you will say that, of course, if in order to get the same amount of torque, the amount of effort required is less, then this one is better. Such situation is called as self-energizing. Self-energizing. How in actual we define self-energizing? Self-energizing is defined when the moment because of the actuating force and the friction force, once again listen to it very carefully, once the moment because of the actuating force and the friction force about the pivot point on your block lever arrangement. I am not talking about drum. Okay, everything I am defining with the help of the FBD of block lever arrangement itself. Okay, so here if the direction of torque because of friction and P, direction of torque because of friction and P, here also the friction is causing the anti-clockwise torque, P is also causing the anti-clockwise torque. So here basically we are talking about a self-energizing brake, and in self-energizing brake the amount of effort which is required is less. So this is how we define self-energizing brake. Okay, so here you can see the definition of self-energizing brake. If the moment due to frictional force and the moment due to external effort about the pivoted point on block lever arrangement, okay, on block lever body are in same direction, then such arrangement is called then such arrangement results in the self-energizing brakes. The point is that, okay, as far as effort is concerned, this seems good that, okay, we are getting self-energizing brake, the amount of effort is required is less. But here if I will say that in case somehow accidentally it happened that B became less than mu C, then what will happen? If B became less than or equal to mu C, then in that case we say that in order to apply the brake, in order to get the N, we need 0 P. We don't need any P in order to get this N. Okay, the brake will automatically be applied, and therefore this condition is called as self-locking brake. Self-locking, and self-locking is something which is not at all suggested. It will cause the accidents. Okay, self-energizing is fine, but you should be very, very careful with the self-energizing brakes. There is one positive side, there is a negative side as well. Here there is only possibility of getting the self-locking in self-energizing, or else in the other case there is no possibility of getting self-locking. Okay, in any of the, for any of the value of B or C or A or mu, you are not going to get the negative value of P or 0 value of P. Is it fine? So here there is no possibility of self-locking, but in case of self-energizing there is a possibility of self-locking. So you have to be very careful if you are using the self-energizing brake. Fine. So let's see the problem first. For the brake shown in figure, which one of the following is true? Self-energizing for the clockwise rotation of the drum. Let's say the rotation of the drum is clockwise. The direction of friction on the drum will be towards left. The direction of friction on the block will be towards right. Okay, we are just concerned about the direction of friction on the block itself, because we have to calculate, we have to watch that, okay, the moment because of the friction and F on the block lever arrangement are in same direction or not. So because of this friction F, you can see this will be the moment arm. So it is basically causing the clockwise movement, and as far as F is concerned, this will be your moment arm, and this is also causing clockwise moment itself. So friction and F on block lever arrangement. Once again I am saying, once you are confirmed that, okay, what is the direction of friction? What is the direction of friction on the block? Then you don't have to get worry about the FBD of the drum. you don't have to consider your drum into your free body diagram. Straight away, with the help of free body diagram of your block lever, you can straight away say that whether the brake is self-energizing or not. Okay, so here the friction and F both are causing the clockwise torque, therefore this particular case is a self-energizing brake case. Fine. Now let us move to the band brake. Here if I will say that how do we define band brake, so instead of a block which was initially at rest, here it will be the band which will be bringing the body to rest. This is the band, this is your band, this is your band, this is your drum, which will be either in clockwise rotation or anti-clockwise rotation. With the help of this band, with the help of this tensions in the band, you will ultimately bring this body to rest. Fine. If someone will ask from me that okay, as far as FBD of the band is concerned, how do we go for the FBD of block and band, sorry, drum and band? Fine. So this is the FBD of drum and band. F2, F1. I'm not saying that which of the two is greater, F2 or F1. I'm not saying that, because it will depend upon the direction of rotation. Say if the rotation is in clockwise direction, then it is mandatory for you to get net anti-clockwise torque, or else it is not possible for you to apply the brake on the body. Okay, the tension itself will decide it, and F2 will become greater than F1 if clockwise rotation is there. If anti-clockwise rotation is there, F1 will ultimately by itself will become greater than F2. How it is coming? It is coming by the fact that okay, if the body is in rotation, the friction on the body will be in this direction, the friction because of this interaction on the band will be in this direction. So straight away you can say that okay, this friction plus this F1 must be equal to F2, therefore F2 must be greater than F1. Okay, so this thing will be cared by the friction, this thing will be cared by the mechanics. You don't have to get worried about that. You just have to apply the common sense. You have to understand the fact that okay, if the rotation is clockwise, definitely it is mandatory to get net anti-clockwise torque in order to apply the brake, and it is possible only when F2 is greater than F1. If anti-clockwise rotation is there initially, then in that case F1 must be greater than F2. Fine. So here let us talk about what are the relations which you must be knowing. So first and foremost point, you should be able to understand the braking torque once again over here. Just watch the FBD carefully. The F2 is causing anti-clockwise movement, F1 is causing clockwise movement. F2 is causing how much anti-clockwise movement? F2 is of course acting tangentially, and the moment arm is R, or you can say small r, whatever you want to use. In the same way F1 is there and the moment arm is once again R. So from F2 we are getting F2 into R, from F1 we are getting F1 into R. F2 into R anti-clockwise, F1 into R clockwise. So basically we are getting, in order to get net anti-clockwise torque, we must be telling that okay, MT must be equal to F2 into R minus F1 into R, or F2 minus F1 into R. Fine. So braking torque basically is equal to T maximum minus T minimum into R. In this particular case, it is defined like that it will be equal to F2 minus F1 into R. Fine. The second point is that whether there is any relation between T max and T minimum as far as the band and this drum is concerned. So we already know that yes, there is a relation which once again come from the mechanics itself. T max by T minimum is equal to e to the power mu theta. How do we get that? With the help of FBD of the band. With the help of FBD of the band, we get this relation. After integration, we get this relation T max by T minimum is equal to e to the power mu theta. In this particular case, it is F2 by F1 is equal to e to the power mu theta for clockwise rotation. Okay, so this is the second relation. Fine. And once again, here in the, as far as gate is concerned, you will be provided that okay, this much of actuating force has been applied. What will be the amount of braking torque, or if this amount of braking torque has been applied, what must be the value of actuating force? So ultimately you have to use the FBD of the lever. Once again, it is not possible for you to proceed just with the help of FBD of the band and drum. So here let's say Rx, Ry is there, Ry, Rx is there. Of course, once again, net moment about hinge point should be 0. So this is 0. Sorry, O, net moment about O must be 0. And from here you can say that okay, P1 into L plus F2 into A must be equal to F1 into B. How we are writing this equation? We are writing just by the fact that okay, this lever was in equilibrium and this was hinged about point O. Definitely the net moment about point O must be 0. From here you are getting this relation. Okay. So these three relations you should be able to understand very carefully. These are the only concepts which are used over here, nothing else. T max by T minimum is equal to e to the power mu theta. T max minus T minimum into R is equal to MT. And as far as last relation that is important is net moment about point O must be equal to 0. I'm not asking you to memorize these things. I'm just asking you to keep in mind these particular cases. Fine. Let's move further. Classification based upon the ends of the where these ends of the band are founded. So it could be either simple band break or it could be differential band break. If any of the end of the band is there on the pivot, then we are talking about a simple band break. If any of the end is not on the pivot, both of the ends of the band are on the lever itself, then in that case we are talking about a differential band break. Okay. So here you can see the definition. In this arrangement, one end of the band is attached to the pivot and the other end of course one end should be on the brake lever, or else it is not possible. If one end is not on the lever, one end of the band is not on the lever, then it is not possible for you to apply the brake. Okay. So one, so definitely it is mandatory to be on the lever. One could either be on the lever or it could be on the pivot. If it is on the pivot, then we are talking about a simple band brake, and if it is not on the pivot, then we are talking about a differential band brake. Here once again, if someone will ask from you that okay, as far as let's say that clockwise rotation is there, so if the clockwise rotation is there, so F1 must be greater than F2. Definitely MT must be equal to F1 minus F2 into R. Fine. F1 by F2 must be equal to how much? So F1 by F2 must be equal to e to the power mu theta. These relations holds good. Okay, just by the common sense. And after that, net moment for this block lever arrangement. For this block lever arrangement only I am talking. Okay. Last equation what I am writing here. So this is F1, this is F2. So from here you can straight away say that net moment about point O must be 0. Let's say this is point O, hinge point. From here you can say that okay, F into L must be equal to F2 into B. Of course F1 is passing from the pivot itself, so no momentum corresponding to that. F1 must be equal to F2 into B by L. So these relations you must be able to understand. first, second and third. Now, if I am talking about the differential band break, then in that case we have to understand that both of the ends should not be, either of the ends should not be there on the pivot. So from here, once again, if I will ask from you that okay, the clockwise rotation is there, say clockwise rotation is there. So from the FBD, F2 must be greater than F1, unless you are not mentioning that okay, the rotation is clockwise or anti-clockwise, you cannot move further. Okay, so F2 is greater than F1 provided the clockwise rotation is there. MT is equal to, once again, F2 minus F1 into R. If I will say net moment about point O is equal to 0, F2 by F1, of course, F2 by F1 is equal to e to the power mu theta. Net moment about point O is equal to 0. From here you can say that okay, P into L plus F2 into A must be equal to F1 into B. From here you can say that P must be equal to F1 into B minus F2 into A upon L. Now, there lies an interesting point. If I will ask from you that as far as self-locking is concerned, as far as possibility of self-locking, I'm not saying that in this case there is self-locking occurring. Okay, unless the P's value greater than 0, then self-locking is not there. If I'm saying that possibility of self-locking is there with which of the band break, simple band break or differential band break, then you can observe it very easily that as far as simple band break is concerned, never it is possible to have a self-locking condition, because there will only be one force, and because of this this will be having some moment about hinge point, and this should be balanced, and therefore we should be requiring the external force acting in such a way that the moment could be balanced on the lever. Fine. So F could not be 0 or less than 0 as far as this. It could be greater or less, but it could be greater than 0 definitely. Okay, it could be higher or lower, but it could be greater than 0 for sure. It could be positive. It is going to be positive for sure. F2 into B by L. But as far as this particular relation is concerned, P is equal to F1B minus F2A upon L. Here what is happening? Here you should be able to understand that depending upon this F1, F2, F1 could be greater than F2 depending upon rotation. Okay, even B could be greater than A depending upon the geometry. Very simple. So depending upon the magnitudes of this B, F1, F2, F3, it is possibility to get the negative value of P as well, to get the 0 value of P as well, and then there will exist the self-locking condition. So here self-locking is possible. I'm not saying always, but here self-locking is possible. Fine. When it will be having self-locking condition, when the P is less than equal to 0, basically when F1 B minus F2A is less than equal to 0, or you can straight away say that F1 by F2 is less than equal to A by B. This is not something which you have to memorize. This is something which you just have to observe. Okay, A, B, C, you don't have to memorize anything. Now F1 by F2 will, whether it will be equal to e to the power mu theta or 1 by e to the power mu theta, that will depend upon which of the two is greater. So you don't have to memorize anything. You just have to understand that okay, here there is possibility of self-locking. In simple band break, there was no possibility of getting the self-locking condition. Fine. Let's move further. Let's just see your another previous year. A block break shown below has a face width of 300 mm and the mean coefficient of friction to be 0.25. For the activating force of 400 Newton, the braking torque is. So first of all, the most important thing which we have to understand, that what is the direction of braking torque. So as far as friction on the drum is concerned, this is the FBD. Braking torque is how much? Braking torque is Fr into R. Fr is how much? Mu into N into R. Fine. The point is you have to determine the value of N. From where you are going to determine the value of N? You can determine the value of N only from the free body diagram of this block lever arrangement. So this is my 400. Okay, let's draw it separately. So this is 400 Newton. This is normal. And the direction of friction on the block lever arrangement will be this. However, here somehow they have managed that the direction of rotation is not actually causing any effect. Okay, why? Because the friction itself is passing from the pivot point. So you can say that net moment about point O is equal to 0, will provide you the relation 400 into 600 must be equal to N into 200. From here you can calculate the value of N to be equal to 1200 Newton. Fine. Once you have calculated that, okay, the normal action between both the surfaces are 1200 Newton, now you can calculate the braking torque as well. The point is, just watch the geometry carefully. From this dashed line, the position of the hinge is at 150 mm. Here in this question, the dia is also provided to be 300 mm. Okay, here it is 300 mm. So basically the radius is 150 mm, and therefore you can say that the friction is acting parallel to the dashed line at a distance of 150 meter, and therefore the line of action will pass from the pivot point itself. Okay, so this is something which you have to understand, and from there you should be able to determine the value of this normal action, which is 1200 Newton. Once you have calculated the normal action value, then you can straight away move further. You can put this value N into the braking torque formula, and from here 0.25 into 1200 into R. R is the radius, which is 0.15. Okay, so 1 by 4, 300 into 0.15. Basically this will be equal to 45 Newton meter. I hope this point is clear to everyone. From here you will be getting the value of braking torque to be equal to 45 Newton meter. Fine. Let's move to the next problem. The band brake having the face width is provided 80 mm. Drum diameter is also provided 250 mm. The coefficient of friction is provided, mu to be provided as 0.25. The angle of wrap theta is provided as 270 degree, or you can say 3 pi by 2, okay, radian. Required to exert the friction torque of 1000 Newton meter. So MT, they are telling the MT is equal to 1000 Newton meter. The maximum tension developed in the band is, they want to calculate the maximum tension in the band. We know that MT is equal to how much? MT is equal to T max minus T minimum, into R. Okay, straight away we don't know that, okay, what is T max, what is T minimum. In question they are asking about T max itself, but this relation definitely holds good, that MT is equal to T max minus T minimum into R. We know that this is MT is equal to 1000 and R is equal to 0.125 meter. From here you can say that, okay, T max minus T minimum will be equal to how much? Will be equal to 1000 by 8000 basically. This will be equal to 8000. This is the first relation which we got. Okay. After that we also know that T max by T minimum is equal to e to the power mu theta. On solving this, on substituting the value 0.25 into 3 pi by 2, you will get this value to be 3.248. From here you can get, okay, you need to calculate T maximum, so you have to replace this T minimum in terms of T maximum. You can say that T minimum will be equal to T max upon 3.248, which will come out to be 0.307 T max. Once you have got this second relation as well, Then from here you can substitute the value of T minimum in the equation 1, and from there you can calculate T max into 1 minus 0.307. This must be equal to 8000 Newton. From there you can calculate this T max will be equal to 11,560 something Newton. Basically in question they are asking about kilonewton, so we can straight away say that okay, this will be 11.56 kilo Newton. Fine. You should be very careful about the unit in which the answer is asked. It is possible that every concept you are going to apply correctly, but if in case you are dealing with a numerical answer type question and you don't really watching the options there, then in that case there is possibility that you can do the mistake. So be very careful about the unit in which they are asking the data. Fine. Let's move to the next topic, which is clutch. Now we should understand that how the clutch works. Okay, basically there is a prime mover, basically there is a driving shaft. Now this driving shaft is attached with the power source. Okay, this is driven member, driven shaft. This driven shaft is attached to the load. Now initially this driven shaft was at rest, and once it will come in contact with the driving shaft, then it will start rotating also. How it is coming in contact? With the help of this engaging forces which are coming from this friction, which are coming from this arrangement. So this is F. Okay, whatever this F is, whatever this W is, whatever there must be some force basically in order to bring both the surface to be in contact. One surface is under rotation, another surface was at rest. Because of the relative motion, the friction will come into existence, and that will cause this both the bodies to move together. Okay, because the friction do apply in such a way that it wants to stop the relative slipping. So in order to cease the relative slipping, the friction will act accordingly, and ultimately you will get a situation when both of them will rotating together. Fine. So this could be done with the help of coupling as well. But the point is, as far as coupling is concerned, it is not possible for you to separate the driven and driving shaft on your wheel. Okay, it is not possible for you. You just have to remove all the bolts and every joints in order to separate the two. Therefore, we cannot use coupling if we want intermittent working. Intermittent working means you don't want the prime mover to stop, you don't want your engine to stop, you just want to have zero output for some time. Okay, like you are there on the red light, you don't want to stop your engine, you just want to stop moving. There is no load, so there is no output requirement. You can on your wheel separate the power source with the output. Fine. There where we are talking about the intermittent working, if we want to have a machine which is working for continuously 24 hours 24/7 for months, for years, then in that case we don't need clutch. Then in that case it is better to have coupling or something. Okay, but if we are talking about intermittent working, if we want to have a situation where on the wheel of operator within some time, within some 10 minutes, 20 minutes, 40 minutes, we want to disengage the power source, then in that case it is best to have the clutch. Now if I will define clutch, then this clutch is defined as a mechanical device which is used to engage, disengage the driven shaft to and from the driving shaft at the wheel of operator without stopping the prime mover. The clutch is used to avoid the frequent stopping and starting of the prime mover. When the machine required intermittent service, clutch is required. Fine. Let's say, what are the classification of clutch? So clutch classification is, it could be either friction clutches or it could be jaw clutches. Basically, instead of this plain surface, there will be some projections. And there will be some interlocking, and with the help of those interlocking, more torque can be transmitted. But once again, the jaw is not there in your syllabus, first thing, and the second thing is there are some you can say there are some flaws also which are associated with the jaw clutch. like that you cannot engage both of them when there is load, you cannot engage both of them when the speed is high. Okay, so jaw clutch also have their problems. However, it is, if as far as the amount of torque transmission is concerned, it is definitely having the greater value. But the point is, jaw clutch is not there in your syllabus, so you don't have to worry regarding that. And in jaw clutch there is square, spiral or sawtooth depending upon the type of the projection. Basically the projection will be there and the interlocking will be there, and that is the main cause of power transmission. Okay, here in the friction there is no interlocking, it is just the surfaces in contact, one surface in motion with respect to the other surface, and from there you can straight away say that okay, what is the amount of torque that can be transmitted. Here there is a possibility of torque transmission either with the help of radial or axial. As far as axial clutches are concerned, it could be plate clutch or cone clutch depending upon the amount of torque you want to transfer. As far as plate is concerned, single plate or multi plate, once again depending upon the dimensions which is available to you, the radial space which are available to you, or the amount of torque which you need to transmit, depending upon that there are some classifications. Okay, as far as radial is concerned, can anyone tell what is the example of radial? So it is centrifugal clutch, which was used in mopeds, very standard clutch, which itself will decide that okay, whether I want to be in contact or not depending upon the rotation, self-adjusting. Fine. Now we just have to work for this friction clutches only. Let's see. First of all, let us go through this theoretical point of view, that as far as this friction line is concerned, what should be the properties? Okay, so the properties associated is that the high coefficient of friction must be there. Of course, if the friction is the cause of torque transmission, if the coefficient of friction is less, that amount of torque transmitted will also be less. Fine. So high coefficient of friction is required. High thermal conductivity is also required, because the friction is there, and while engaging, disengaging, whenever there will be some relative slip, the friction will be doing work, and whenever the friction will be doing work, the heat will be generated, and if there is no enough amount of thermal conductivity, then the temperature of your product will increase, and if the temperature of your product will increase, the possibility of being damaged will also increase. Fine. So high thermal conductivity is required so that the temperature will not rise too much. Fine. High wear resistance, of course, the friction is the cause of motion transmission, so friction is also cause of wear resistance, wearing out. In order to have the life of our clutch to be on the higher end, we need to have high wear resistance as well. In the same way, less thermal expansion is also required. Say, definitely there must be some temperature rise, and in corresponding to that temperature rise, if there will be deformation in the body, then in that case, whatever we have designed, the work will not be accordingly. Okay, so we have to look for the material which is having some less thermal expansion as well. And of course, the high strength is required. High strength is something which is required for any material, for any element. Okay, until unless it is not designed for the safety point of view. Fine. So this is something which we have understood as far as theory is concerned. The point is how the friction is acting. The two plates are coming in contact. Okay, just see here. Let us say that we are observing from this side. Okay, so that when I will say clockwise, anti-clockwise, then you will be able to understand. I am observing it from here. Right now this body was at rest, this driven member was at rest. What was the direction of rotation? The direction of rotation was counterclockwise as far as this observer is concerned. So you can say that this point is moving towards right. If I will be able to prove that okay, what is the direction of friction, what is the direction of normal direction, how the friction will be acting, then it is very easy for you to apply it for the other points as well. Right now I am just, with the help of this diagram, I am just explaining for the circumference. Okay, so this point, which is somewhere, say for example, if I am talking about this particular cross section, so somewhere over here I am talking about this point. So this point has a tendency to move towards a particular direction. Now because it is moving towards particular direction, and once both of them will come in contact and the normal reaction force will occur, so the point having the tendency to move towards particular direction, the friction force will start acting opposite to that. On the driving shaft I am saying, on the driving shaft, the friction force will be in this direction. Okay, this is the direction of velocity, the friction force will be in this direction on the driving shaft. Now as far as this driven shaft is concerned, this driven shaft will be having the friction in the opposite direction, and you can see that if the friction on the driven shaft is in this direction, of course I am talking about the surfaces in contact. Okay, now because of this friction about this particular axis, you can understand that the moment arm is there, which is whatever r. Okay, we are talking about circumferential element, so for that this is r. It could be anything from 0 to r. Basically this friction is causing counterclockwise movement on the driven member itself. Therefore it will ask the driven member to rotate counterclockwise, as was the direction of driving member. So if it was rotating counterclockwise, as far as observer is concerned, the driven member will also rotate counterclockwise. The slipping will be there until and unless both will start moving with the same direction. Until and unless there is slipping, the friction will keep on acting. The friction will keep on acting. Of course the load is there, so always there is the requirement of friction. Okay, fine. So this is something which you have to understand as far as the torque corresponding to the friction is concerned, and how the friction basically enabled this driven member to rotate in a particular direction. Now let us see here with the help of line diagram. Now if I will say that okay, this is all about the friction and the torque corresponding to that, so we should be able to understand that what is the amount of friction force. So for that we should be able to understand that what is the amount of normal reaction force, what is the normal reaction on the surface. Okay, so this is the W, which is the engaging force, you should be understanding this, that okay, this is the W, which is the engaging force. And if I will say that the normal reaction between both the plates is N, the normal reaction both the plates is N. Okay, all these forces are accumulating to form N. Fine. So if I will ask from you that what should be the value of N, so N should be equal to W. N should be equal to W. The point is that how this N is distributed on the surface. The point lies that how this normal reaction is distributed on the surface. Is it like that whatever normal reaction, intensity of normal reaction is here, the same intensity is here, the same intensity is here, the same intensity is everywhere? Is it like that, or there is something else? Fine. So that is something which we have to understand from this particular topic. Basically here if I will say that okay, right now I don't know that what is the distribution of how this normal reaction is distributed between both the surfaces, but the point is, for any case, as far as symmetry is concerned, for this elemental area, for this elemental circumferential area, you can definitely say that whatever intensity of normal reaction will be at this point, the same 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 will be throughout the element, throughout this elemental area. How we are so sure? Because of the fact that this is symmetry. I'm not saying that the clutch is old or clutch is new, the pressure is uniform or the pressure is not uniform. I'm not saying that. I'm just saying from the concept of symmetry, definitely this elemental area will be having the same intensity of load. So we are just saying that okay, let's say the intensity of load is P. The pressure at this particular area is P. So how much will be the dN for this particular area? So the dN for this particular area will be, this was the first thing which you should be able to understand. Okay, the second thing is we are calculating dN first, because we don't know that how this normal reaction is distributed. Okay, so dN is equal to P into 2 pi r dr, P into the elemental area. If I will integrate it, you will be able to calculate the value of normal reaction as well. This will be P into 2 pi r dr. This is your first relation which is there, which is definitely there, independent of how this P is distributed, how this normal reaction is distributed. Okay, The second point is if we want to calculate the value of MT, torque transmitting. So we know that as far as normal action is concerned, as far as the intensity of the pressure is concerned, it is perpendicular to the screen. But depending upon the relative motion, the friction will be acting tangential to that. So this will be the direction of friction. Okay, this will be the direction of friction acting tangential. It could be clockwise, anti-clockwise, anything, but this will be the direction of friction, and this friction will be causing your moment. Fine. Now if I will say that what is the magnitude of this friction, so you will say that this will be equal to mu times of n. Say we are talking about dn over here now. And what will be the torque corresponding to this friction? So you will be saying that this will be equal to mu into r into dn. Fine. So MT is equal to mu into r into dn. Mu into r into dn. This is your torque because of this friction on this elemental area. Okay, if you want to calculate it for the complete area, then you have to integrate it. Now if I will ask from you that okay, mu into r into dn we already know dn is equal to p into 2 pi r dr. So you can say that okay, the MT could be written as the integral of mu into 2 pi p r square dr. This is the second relation which holds good, and it is independent of whether we are talking about a new clutch or old clutch. Now here if I will say that okay, let's get some specific data. So you can say that okay, as far as new clutch is concerned, the intensity of the pressure through the intensity of the normal action throughout the area should be same. Why it is? Because the thickness of the friction lining is same throughout, from R2 to R1, from Ri to Ro, the thickness of the friction lining is same. Therefore definitely it is there that whatever contact they are having, the contact will be such that the intensity of normal action will be same throughout the area. So you can say that for new clutch the pressure will be constant, and this theory is called as uniform pressure theory. Fine. Now if I will say that okay, corresponding to uniform pressure theory, P becomes constant. So what will be the value of N? So you can say that the value of N will be determined using this formula, equation 1. So N will become equal to, P could be taken out, 2 pi r dr. On solving this, Ro square minus Ri square by 2. Basically on solving this further, you can say this will be equal to P into pi Ro square minus Ri square. And this should also come now. This is something which should be coming out. Why? Because the pressure is uniform and the area is pi into Ro square minus Ri square. Definitely this is the amount of normal reaction which we are getting from the interaction. Fine. Now what about MT? How do we calculate this value of MT? So if we want to calculate the value of MT, then you can say that okay, the MT could be equal to 2 pi mu P I can take out, R square dr will be there. This will become Ro cube minus Ri cube by 3. 2 pi mu P. Now this is one form of MT, but the more famous form of MT is writing this MT in terms of W. Writing this MT in terms of the axial force. Okay, straight away in terms of axial force. In terms of normal, W basically is equal to normal. So in terms of W or N or axial force, you can write it. So P could be written as, P we know that P could be written as N upon pi Ro square minus Ri square. So this if you are going to place it in the equation will become like this: 2 pi mu into N upon pi Ro square minus Ri square into Ro cube minus Ri cube by 3. On solving this, you can find that okay, this pi will get cancelled, and from here you can write this form as mu into N into 2 by 3 Ro cube minus Ri cube upon Ro square minus Ri square. This formula you have to keep in mind. MT for uniform pressure theory will be equal to mu into n 2 by 3 rho cube minus ri cube upon rho square minus ri square. Now if someone will ask from me that okay, how can we watch this equation in a different way, so you can understand that if instead of saying that the normal reaction is distributed throughout, instead of saying that, I am just saying that the normal reaction is acting at some point over here. The friction will also be acting at some point over here, and this friction will be equal to how much? Mu into n. And how much will be the value of the torque because of this friction? So this will be equal to mu into n into Rf. Mt will be equal to mu into n into Rf. Rf is the position where you can consider your whole friction to be acting at, and from there you can say that okay, this Mt will be equal to mu into n into Rf. This is something which is just an analogy. Okay, if something like that happens, then corresponding to that you can say that okay, this must be our Mt. This is not in real. Now if you will compare this formula with this particular formula of Mt, then you will find that okay, this Mt is equal to, as far as uniform pressure theory is concerned, Mt came out to be mu into n into 2 by 3 rho cube minus ri cube upon rho square minus ri square. From here on comparing, you can say that okay, as far as this portion is concerned and this portion is concerned, it seems similar. So you can say that okay, n can be assumed to be acting at a distance 2 by 3 rho cube minus ri cube upon rho square minus ri square, and corresponding to that the friction must be acting over there, and corresponding to that the friction torque is mu into n into Rf. Fine. So this is something which you have to memorize basically, that Rf for uniform pressure theory is equal to 2 by 3 into rho cube minus ri cube upon rho square minus ri square. Fine. So this is the relation which is very, very important. Moving further, if I will talk about that after some time what will happen. So after some time uniform pressure theory is applied. Uniform wear theory is applied. What is uniform wear theory? Uniform wear theory is applied to the old clutches. It is applied to the old clutches, and it is applied when we get PR is equal to constant. How this PR comes to be constant? This is something which is not mandatory for you to understand as far as gate is concerned. Okay, never ever ask that how this PR becomes constant for your uniform wear theory or for your old clutch. How this happens, they haven't asked basically, but this is very interesting, and so I want you to understand this. Just try to relate it. Say I am talking about the same area, okay, say this is A and this is also A, but one area is at a distance R1 and one area is at a distance R2 from the axis of rotation. Fine. So if I will say that okay, initially everything was very new, everyone was having the same amount of interaction with each other, so whatever normal reaction which we will be getting from here, the same normal reaction we will be getting at the A2 as well. So this is your A1 and this is your A2, and both A1 and A2 are same. This is just to understand. You don't have to get worried regarding this. Now if I will say that okay, the pressure intensity was same, therefore definitely the dN will be same, P into area, or you can say normal action will be same. Okay, we are just interested in the normal action at this point and normal action at this point. I am just comparing what is happening at both the points at both the radial distances. Okay, so n, this is not the complete n, this is the n which is associated only with the area A1, area A2. Both the areas are same but at different radial position. Okay, so n is equal to P into A. From here you can say that okay, mu into n will be equal to friction. So basically mu into P into A will be equal to friction. And if I will say that okay, what will be the value of torque? So this will be mu into n into R1 or R2. So if I will say MT1 will be equal to how much? So you will say that mu into PA into R1, and in the same way MT2 will be equal to how much? Mu into PA into R2. Fine. Now this is the amount of torque which is basically transferred with the help of friction at elemental area A and at elemental area A1 and elemental area A2. Fine. Now if I am talking about a situation where there is a relative slip, until unless there is no relative slip, this point is cannot be made. Okay, there is relative slip and the relative angular velocity. Relative angular velocity is omega. Say relative angular velocity between the driving and the driven plate is omega. Then in that case you can say that the work done by friction per unit time. Work done by friction per unit time means friction torque into omega. Fine. So work done by friction per unit time will be how much? This will be equal to mt into omega. This will be mu into P into A into R1 into omega. Omega for both is going to be same. So basically this is the work done on element 1. For element 2 you can apply R2. The point is, the more is the work done by friction, the more is the wear. Okay, more is the heat generated, more is the amount of heat generated, and correspondingly more is the amount of wear out. So you can say that at a larger radial distance, at the greater value of position of this elemental area, you will be getting the larger wear out. So here the wearing out will be greater in comparison to this case. Here the wear out will be less. Here the wear out will be greater. Ultimately your friction lining will start appearing like this. It will start appearing like this. Radially outward, more wear out. Radially inward, wear out is less. So it will appear like this. And if this will happen, then at that very moment, what will happen? At that very moment, the interaction between the two plates will not remain same throughout the radius. It will, at radially outward, the amount of interaction becomes less. Therefore, correspondingly, the amount of normal action also decreases. Correspondingly, you can say the amount of pressure will also decreases. Okay, so from there you will be getting some value of P1 at elemental area A1, and in the same way you will be getting some value of P2 at elemental area A2. Now this thing will keep on happening. Once the normal action will decrease, the amount of P will decrease. If the amount of P will decrease, the work done by friction at outer surface will decrease, and then the wear out at the inner portion will keep on increasing. Somehow after a time it will happen that the wear rate at both the radially inward and radially outward at all the radial position will become equal. Then the wear rate will start to be same. Pressure is not uniform, but the wear rate will become constant. So here you can say that okay, mu into P2 into A into R2 into W will become equal to mu into P1 into R1 into A into W. On watching it carefully, you can cancel mu A W, and basically P1 R1 will become equal to P2 R2 when the wear rate is same. And this is the state for which we are talking about. Okay, so when P1 R1 becomes equal to P2 R2, or you can say which becomes equal to PR, or which becomes equal to constant, this is the point about which we are talking. So one case is when the pressure is uniform, and one case is when the PR is constant. Okay, so this is something which you have to understand. Now if I will say once again that okay, what about n? So you can say that this is integration of P into 2 pi r dr. So straight away you can say PR is constant. From there you can take out 2 pi PR. PR is basically constant only, so you can write it as C also. Okay, dr. So from here you can write 2 pi C into RO minus RI, or you can write it like 2 pi into PR. PR means PIRI or PORO or P into R, P at any real distance R. So let us write it as PIRI. You can write it as PORO also. You can write it as P into R as well. RO minus RI. This is the formula which you have to understand, which you have to keep in mind. Fine. Apart from that, if someone will ask that, okay, what about empty? So empty will be equal to, in the same way, mu into dn, which is P into 2 pi R dr into R. So this will become equal to mu into P into 2 pi R square dr. On solving it, you can take this P, R and everything constant outside. So mu into 2 pi R dr. So this will become equal to R square minus R square by 2. 2 pi mu into C into R square minus R square by 2. C you can write in terms of n. C you can write in terms of n or W, whatever you want to say. So this will become 2 pi mu into n upon 2 pi RO minus RI into RO square minus RI square by 2. From here you can write that, okay, this pi will cancel out. RO square minus RI square will be equal to RO plus RI into RO minus RI. So this will become RO plus RI, and RO minus RI will get cancelled from both the side. Basically you will get this 2 will also get cancelled. Basically you will get mu into n into RO plus RI by 2. So empty will come out to be mu into n into RO plus RI by 2. If I will ask from you that, okay, what will be the equivalent radius in this particular case? So here RF will be equal to RO plus RI by 2. If someone will calculate for any particular value of RI and RO, you will be able to find that this RF, this equivalent radius corresponding to uniform wear theory, is relatively less than what we have got from the uniform pressure theory. Okay, for particular value of RI and RO, whatever value you want to put it, okay, 5 mm, 10 mm, 50 mm, 100 mm, whatever value you will be putting, you will be able to find that, okay, the RF for this uniform wear theory is less than that from the uniform pressure theory, and that is the cause why the amount of torque transmitting ability decreases. It is not that the axial force will decrease. The axial force is going to remain same. It is the amount of your equivalent radius, because the torque depends upon the normal as well as the moment arm. Here the normal will remain same, but the moment arm will decrease, and therefore the amount of torque transmitting capacity will decrease. Fine. So these are the formulas which you have to keep in mind basically. Okay, so as far as the from gate point of view, we have covered almost everything. Some more points you just have to watch, observe it. Let us talk about multi-plate clutch. However, this is not very important. In 90s, the question was asked. Once the question was asked, if someone will ask that, okay, what is the amount of torque transmission from this multi-plate clutch? So whatever empty you have got for uniform pressure theory or uniform wear theory, as far as single plate clutch was concerned, then empty for multi-plate clutch will be equal to n into empty, where n is the number of interacting surfaces. Now how do you find this number of interacting surfaces? You can just by observing these two, just by observing, or you can use this n to be equal to n1 plus n2 minus 1, where n1 is the plate on the number of plates on the driving member, driving shaft. N2 is the number of plates on driven shaft. And in the same way, if I will ask that from there you can calculate the value of N, you can calculate the value of MT. So from here you can very easily say that okay, the torque transmitting capacity corresponding to the multi-plate clutch is higher than that of the single plate clutch. Then is it that we always go for the multi-plate clutch? No, it is not mandatory that we will always go for the multi-plate clutch, because multi-plate clutch is only will only be suggested to use when there is your constant as far as radial space is concerned. If you have sufficient radial space, then you should be going for the single plate clutch itself. Okay, you should be increasing your RO so that the amount of torque transmitting can be increased. The point is, what is the issue with the multi-plate clutch? The main issue with the multi-plate clutch is the heat transmission. Whatever heat is generated in this multi-plate clutch, it cannot be easily taken out. Therefore, we have to use the coolant and all. And if we will be using coolant, then basically we are reducing the coefficient of friction. And if we are reducing the coefficient of friction, basically we are decreasing the effect of friction. The friction is the main carrier of this whole system, and if we are decreasing the friction because of any reason, then ultimately the effectiveness of this system is decreasing. Okay, so the point is, until and unless you are free to use any amount of radial space, then better to go with the single plate clutch, or you can use the multi-plate clutch, but it have its own, you can say, designing problems. Fine. So this is the formula which you should be able to understand. All the concepts will remain same. Uniform pressure theory, uniform wear theory, everything will remain same. This is the only two relations which you should take from here. Fine. Moving to the next, cone clutch. If I will say that MT for cone clutch, this will be equal to 1 by sine alpha of MT for single plate clutch. Fine. The concepts will still remain the same. Here if I will say that what is sine alpha, then just watch here, because this is forming an imaginary cone. This is a part of an imaginary cone, and this imaginary cone will have some apex angle. Let's say this apex angle is 2 alpha. So the alpha is the semi apex angle. You can say alpha is the semi apex angle. Now if this alpha is semi apex angle, you can understand that okay, 1 by sine alpha is something which is greater than 1. Definitely the MT for cone clutch is greater than MT for single plate clutch. Of course, once again it will have its own problems. Fine. This is not very important. The only thing which you have to keep from here, which you have to take from here, is that the torque transmitting capacity will increase by 1 by sine alpha time. Now let us lastly talk about the centrifugal clutch. For centrifugal clutch, you should be knowing the concept of centrifugal force. Centrifugal force is what? Centrifugal force is an inertial force, imaginary force, after application of which we can consider our body to be in equilibrium. However, in real the body is not in equilibrium. In real it is not like that the body is in equilibrium. The body is in dynamic condition. The body must be having some acceleration in a particular direction. But as far as centrifugal force is concerned, it is an inertial force. D'Alembert, the concept of D'Alembert, to bring the body which is actually in dynamic condition, to bring it in a static condition and analyze it accordingly, so that we can have that ease of static equations. Okay, for that this concept was made, and that is something which we should be knowing before going for the centrifugal clutch. Okay, so let's say at any particular, let's talk about any particular drum. Let us talk about this A. Fine. If I will be able to derive everything as far as this block is concerned, then very easily I can say it for the other as well. Fine. So this is my spring. Say this is the axis of rotation. This is the axis of rotation perpendicular to the screen. Okay. Now let us talk about any random position where still there is no contact between the block and the drum, nothing like that. Say the elongation, initially if there is no omega there will be no elongation, considering there is no gravitational effect or something. Okay, so if until unless there is no omega there will be no elongation. But let's say there is some omega, still the body haven't yet reached, still the shoe haven't yet reached to the drum. Right now I am just taking any random position over here. Say the x is there which is associated, or x1 is there which is associated, which is the amount of deformation in the spring. So as far as the FBD is concerned, you can say that okay, the FBD will appear like kx1 and mr omega square, where r is the position of this center of mass of this shoe from the axis of rotation. Fine. This is the centrifugal force which is acting radially outward. After applying this, we can consider the body is in equilibrium, and from here you can say that okay, kx1 must be equal to mr omega square. Fine. Let's say this to be r1 itself. Okay, we are talking about a random scenario, so let's talk about this. Take it as r1. So kx1 is equal to mr1 omega square. In actual, because the body was performing circular motion, the body was having an acceleration towards the center, which is r omega square. In order to bring that body in equilibrium, we need to apply an inertial force which is equal to m into acceleration, opposite direction of acceleration. From there you can say that okay, this inertial force is applying radially outward, and now after application of this inertial force we can consider this body to be in equilibrium. From there you can say that kx1 must be equal to mr1 omega square. Fine. So this is the first equation which we got. Now let us talk about the position. Let us talk about the position when the body is just going to touch the drum. This shoe is just going to touch the inner surface of drum. Okay, this is shoe and this is going to touch the drum. Let's say at this position the deformation in the spring, the elongation in the spring is x, and the position of center is r. So you can say for when interaction just begin, then here you can say that kx must be equal to mr omega square. For that I am writing it to be omega I square. Omega I is not the initial angular velocity. Omega is the angular velocity at which the interaction is starting. Okay, so mr omega I square. This is the more important relation. Fine. Now once this omega will increase from this omega I, let us say that omega I is now increasing from omega I to omega O. Now because omega I increase from omega I to omega O, so you can definitely say that okay, as far as FBD is concerned, definitely the amount of centrifugal force now is equal to mr omega O square, and of course the friction is there which is equal, the spring force is there which is kx. But apart from that, one more force will start acting, and which is normal action, and this is the force which I was requiring. Basically this was the force which I was requiring. So this is n, this is kx. Now if someone will ask from me that okay, how do we determine this n? Because we know that after knowing about this x, the x was corresponding to the point where the body was just able to touch the drum. Now after increasing the omega, only the centrifugal force has increased, only the normal force has increased, but there is no change in the spring force. Why? Because there is no more deformation in the spring. Why? Because the drum is not expanding at all. If drum is not expanding, then there is no possibility of getting the more elongation as far as spring is concerned. So definitely here the kx is same as that of mr omega I square. So from here you can say that n is equal to mr omega O square minus omega I square. Fine. How we are getting this? Let me write it for you. N plus kx is equal to mr omega o square. Kx we already know from equation 1 that it is mr omega I square. So from here you can say that n will be equal to mr omega o square minus omega I square. This is my equation 2. Fine. So this is the amount of normal reaction between both the surfaces when the omega o is there. Now this is the normal reaction, this is the direction of normal reaction, and as far as the rotation is concerned, say this is rotating clockwise, so the tendency of this shaft to be rotating clockwise, tendency of this point to be moved in the upward direction, therefore the friction will be acting in the downward direction. As far as shoe is concerned, the friction will be in this particular direction. Now as far as drum is concerned, the friction will be in this particular direction, and so it will cause this drum also to rotate clockwise. Fine. Now basically we need to know that what will the value of friction. We have already calculated the n, therefore the friction is equal to mu times of n. And if we are knowing that the friction is mu times of n, then we can calculate the frictional torque as well. This will be equal to mu into n into r, where r is not the position of the center of mass of the shoe. The r is the radius of the r is the inner radius of the drum. The r is the inner radius of the drum. The capital R is the inner radius of the drum. If we will substitute each and everything from here, so this mt will come out to be mu into m into r omega o square minus omega I square into r. From here, this was defined only for a single block. So from here you can say that okay, in overall total amount of torque which we are getting from the arrangement is mu into m into r into omega o square minus omega I square into r into n. The n is the total number of blocks. N is the total number of blocks. Okay, you just have to understand that what is r. R is the position of center of mass of shoe. As far as r is concerned, capital R is concerned, so it is the inner radius of drum. Omega o, as far as omega o is concerned, omega o is the angular velocity, the time at which we are talking about. This should be definitely greater than omega I. Okay, and what is omega I? Omega I is the angular velocity when the contact begins. Angular velocity when contact begins. Fine. I think now everything is fine with everyone. Mu is the coefficient of friction, of course, between the surfaces. So this is the final formula which you should be keeping in mind. This was very, very interesting. That's why I have told you. So this is the formula. Basically, we should have gone with the direct formula, but the derivation is very, very interesting. Therefore, I have told you. Okay, fine. So let's move further. A disc clutch is required to transmit 5 kilowatt at 2000 RPM. So basically here we need to have power is provided. Power is provided as 5 kilowatt. Power is 5 kilowatt. This will be helpful to us to calculate the value of MT. Okay, so this power is equal to 5 kilowatt, and omega is also provided. Omega is provided as 2000 RPM. So basically this 5 kilowatt can be written as 5000 watt, and this 2000 RPM can be written as 2 pi n by 60. So this omega is basically 209.43 radian per second. Radian per second. From here you can calculate, you know that power is equal to torque into omega. As for translation it is force into velocity, for rotation it could be torque into omega. From here you can calculate the value of torque, mt basically. So this mt will be equal to 5000 divided by angular velocity, which will come out to be 23.87 Newton meter. So this is our first detail which we have got from the data which are available at the top. After that, the friction is provided, mu is also provided in the question, which is 0.25. The bore radius of the friction lining is equal to Ri, they are providing to be 25 mm. Assume the uniform contact pressure of 1 megapascal. The value of outside radius of the friction is. So here you can say that okay, as far as Ri is concerned is 25, Ro we need to calculate. P they are telling us, which is 1 megapascal. Straight away they are talking about a uniform contact pressure, uniform pressure theory we have to apply. Straight away we know that okay, mt is equal to mu into n into Rf. From here we can say mu into n is equal to how much? Pi into Ro, P into area, area is pi into Ro square minus Ri square into Rf, Rf is how much? 2 by 3 into Ro cube minus Ri cube upon Ro square minus Ri square. This will get cancelled. P you have to put as 1 megapascal. Ro can be easily calculated provided that Ri is equal to 0.025 mm and mu is also provided. From here mt is also provided 23.87. From here you can calculate the value of Ro, which will come out to be 39.4 mm. Okay, this is something which you can go through. So this Ro can be calculated using this formula, and all the data which are available you can easily calculate the value of this Ro, which will come out to be 39.4 mm. Fine, let's move to the next problem, the last problem. A disc clutch is a single with a single friction surface, has a coefficient of friction equal to 0.3. Mu is provided as 0.3. The maximum pressure that can be imposed. So P is told as 1.5. P max is told as, they are not saying that whether it is P minimum or P maximum. They are P inner or P outer. They are just saying that P maximum is equal to 1.5 megapascal. The outer diameter of the clutch plate is 200. So DO is given as 200 mm. DI is given as 100 mm. Assuming uniform wear theory, basically uniform wear theory they are talking about. So they are talking about PR is equal to constant. If in case this was P maximum and the pressure is constant, then in that case throughout the area we can say that okay, this must be the pressure. But here PR is constant, so definitely we should be able to understand that whether this P is PI or PR, PO. Okay, outer radius pressure or inner radius pressure. Fine. Assuming the uniform wear theory, the maximum torque, mt basically they are talking about. So mt is equal to nothing but mu into n into Rf. Okay, let us just find out that whether this P max is PI or PO. Basically we should understand that which of the two must be greater. If we will able to understand that which of the two is greater, then we will be able to say that okay, which one of the two is 1.5. So PI Ri is equal to PO Ro, you can say straight away like that. From here you can say okay, the PI must be equal to PO into Ro by Ri. In this particular case you can say that it should be 2 times of PO. 2 times of PO for this particular case, for Ri and Ro to be 150 and 100 respectively. Fine. Basically PI is definitely greater than PO. So if in case by mistake you have taken PO to be 1.5 megapascal, then in that case PI will become equal to 3 megapascal, and which is not possible. Here they are telling you that the maximum pressure which is allowable is 1.5 megapascal itself. So from here you can understand that okay, PI is the P maximum, and which is equal to 1.5 megapascal. Of course you should understand that as far as the variation of this pressure is concerned, So for uniform pressure theory, it is going to be, let me represent it over here. For uniform pressure theory, it is going to be same throughout. Okay, this is your uniform pressure theory, pressure distribution. But as far as uniform wear theory is there, the pressure distribution will something appear like this. Radially inward, the value of pressure is high in comparison to the outward position radial. Fine. So this is the pressure distribution as far as uniform wear theory and uniform pressure theory is concerned. Fine. Okay. So from here you can say that MT is equal to mu into N into RF. Mu is how much? Mu is 0.3. N is how much? N is equal to Pi Ri into 2 pi Ro minus Ri. This is the formula which you have to keep in mind. Basically, what I am memorizing is, I am memorizing 2 pi R dr, P into 2 pi R dr. Okay, P into 2 pi R dr. This is the formula which I am memorizing basically, P into R. P into 2 pi R dr. From here you can say that okay, whatever P you are using, correspondingly R you have to also use. Dr is something Ro minus Ri. This is the way of memorizing I am telling you. Okay, you can memorize it according to you also. So from here you can say that okay, this is, and what about RF? RF is equal to Ro plus Ri by 2. RF is equal to Ro plus Ri by 2. Basically Ro is equal to 100 mm and Ri is equal to 50 mm. So from there you can straight away say, on substituting all the values, you can find it to be 0.3 into 10 to the power 6, 1 megapascal. So 1.5 megapascal into 530.14. This will be 530.14 Newton meter. Okay, 530.14 Newton meter. So this is something which you can calculate after substituting the value of Ro, Ri, Pi over here. So as far as the clutches and brakes are concerned, no more concepts other than this can be asked. Believe me, and all the best for your exam. I think this session was useful to you. If you feel safe, then please do like, share and subscribe the GATE Academy YouTube channel. Thank you everyone.